question from one of your colleagues regarding advection. And so they went through their forecast and they saw that they kept missing the question on advection. So their question, and it's a great question that many of you probably have, is how do I forecast for advection? Well, let me give you a very simple answer to that. If you go to your information and resources for NASC 102 and go down to your maps to use for forecasting, if you click on surface map questions 1 through 13, it will take you to a map from the Weather Channel. And I'm going to mark this particular surface map up here. Give me just a moment. Now, the simple answer to this for advection can only be caused by fronts, cold front or a warm front. And so, if you are predicting for the next day that no front will pass through, then you can forecast for no advection. Okay, pretty simple. So if I take a look at this current surface map, I see that I have a stationary front back off to our northwest. Stationary means it's not moving our way. There is a trough of lower pressure off to our southwest. That is not a front. And so I don't really see any fronts around Iowa. So I would forecast for no advection. Now, if you were forecasting up here in the northeast, see where I'm pointing, there is a cold front that is moving towards the northeast. And so you would expect in this region colder air. But to determine if it truly is significant advection, we will go back to our maps here. And I have a link for advection. Surface map for temperature advection. I click on this. And recall what we said about advection, significant advection. You have to have at least a 10-degree difference in temperatures across Iowa. So if we look at northern Iowa here, I see a 20-degree isotherm over northern Iowa, and it's still 20 degrees across southern Iowa. So really, there's no advection occurring right now, but you're forecasting for the next day. So if I look back to our north, I see northerly winds up in Minnesota, and there's a 5-10 degree temperature difference across northern Minnesota. However, notice that the wind speeds here are only 5 knots. And to have significant advection, you need to have at least a 10-knot wind speed and at least a temperature difference of 10 degrees Fahrenheit. Well, I have that back to our north. Or at least I have temperature changing rapidly, but I have weak winds. So really no advection occurring. And in fact, the only significant advection that I can find is down here in the southeast over Florida. Look how the temperatures change rapidly from 50, 55, 60, 65. And notice that the winds are from the north. And these winds are 10 to 20 miles per hour. So there is significant cold air advection because the winds are coming in from the north, bringing in cooler temperatures. So I hope you find this helpful. Just keep in mind that if you're forecasting for no fronts the next day, then you will not forecast for significant advection. However, if you think a front is going to pass, then you go to this particular map here and look to see if you have a 10-degree change in temperature with at least 10 knot wind moving into your area over the next 24 hours.